Okay, so just so that my voice sounds the same, we're going to keep everything together. We're going to do another video right now. Today we're going to talk about flashlight myths, common myths. I think I'm going to talk about batteries, which should be the third video in this video series. So with flashlight myths, there's a lot of myths about flashlights. Okay, and maybe the biggest problem that a lot of people have on CAT, other than anti-standard myths, which I explained in another video, and misunderstandings. Okay, there's a lot of misunderstandings. Okay, it is myths about how power works with flashlights. And so this isn't just about batteries, it's about power. And to begin, we'll come back to anti-standard, but when we talk about lumens and how the runtime works, flashlights, there's one myth I've heard several times. Okay, flashlights do not go down in output because the batteries can't supply the ability. Well, this kind of flashlight doesn't. With AA's, AAA's, D cells, those older cell types, 6-volt batteries, anything like that, those big 6-volt automotive batteries, these automotive batteries that were 6-volt with big lights. I'll show you the one that I have later. Those things are not. When those things go down in output, it is because the battery can't maintain it. But this is different. This thing can produce 30 watts per cell almost all the way until the battery's completely drained, down to like 20% power. First 80% of the battery, it can run the same 20 or 30 watts, depending on the quality of the battery, the whole time. Okay? It is not, if it decreases output before then, and it does, it isn't because it doesn't have the battery power. And I heard some weird stuff recently on YouTube and elsewhere on the internet, big misconceptions on how batteries work. That isn't how batteries work. Okay, lithium ion, 18650s and 21700s and 14500s and all these other batteries, 14300s, are special. Then you have 10440s, which are AAA lithium ions, 3.7 volt. And then you have 16340s, which are fake CR123 batteries that are rechargeable, 3.7 to 4.2 volts. Well, 3.7 nominal, 4.2 maximum, and a minimum of somewhere between 2.7 and 3.0. Okay, going less than 2.7 is possible, but it's not usually recommended. Okay, and then 18350s, which are half pint. 18650s they're half the length of an 18650. Okay, there's a few others. They actually now have 21 350s, which are half pint 21 700s. They're not called 350s. They're called, anyways, 21 350s and 26 350s. Okay, and I suppose 26 350s are actually a little bit larger than half the size, but they're not. They really are half the size. So I guess it's really 330 or 330s, and 32.5 millimeters long. Anyways, but I'm not going to split hairs with that. Okay. And I'm not going to talk too much about batteries themselves. I just want to talk about the myths about energy with flashlights. So one of the big energy myths, it doesn't go down in output because it doesn't have the wattage. It goes down in output because it is either too hot or because, number two, it's choosing to go down in output so that the LED stays efficient and it doesn't burn too much of the battery power. This can also be a good warning sign when you don't have something like this, which is a nice green LED, and in real life this is a much nicer green. But in any case, this warns me by turning red and then red flashing when it runs out of power. But there's a misconception out there that flashlights, other than maybe not this particular guy, there's a misconception that flashlights will go down in output because the batteries are running low. No, they'll go down in output because the batteries are running low because the driver's choosing to put it down because it knows the batteries are running down. But that's different than it being forced. It's not forced to go down in output. The driver, the electronic components that take the energy of the batteries and put it into the LED, which are located somewhere in here, these electronic components choose for you how much power to deliver to the LED. And you might say, well, you know what? I don't want to do that. I just want something that runs as hard as it can for as long as it can, like an HID spotlight. Well, that's exactly what this flashlight does. When it's high mode, it's 2500 lumen, high mode, okay, runs for 2 hours and 15 minutes, like this flat line right here, okay, and then the indicator turns red, and the indicator flashes, and then it turns off. Okay, it doesn't give you much of a warning. Okay, I don't think it gives you a warning at all. I think the flashlight just flatlines and turns off. Okay, I've never done it. I've never gone to that because this thing's efficient enough, and I've never had the need to run this thing all the way down. Okay, if I ever did have the need, it was because I'm in some kind of weird ass trouble. Okay, couple that with my knowledge of flashlights and runtime. I usually don't push flashlights too far. I'll be going down to these super long runtime, 27 hours or 7-day modes, way before I would let my light run out of power. Okay, so the second energy myth, total misunderstanding of voltage. Voltage has nothing to do with wattage. And let me put it this way: a 6-volt, which is a big battery used in those old lanterns, and you can find them today in really cheap LED lanterns. Okay, that you hold like this, kind of like this, but they're plastic and everything, and they got a big battery. Those big square batteries, cube batteries, are called 6-volt batteries because they put out 6 volts. It's nothing to do with the wattage. They actually do put out a significant amount of wattage. In fact, they put out a lot more wattage than a 9-volt battery. What? A 9-volt battery is made out of 4 quadruple A cells, which are really tiny, all right, really tiny batteries that are very thin, okay? Not 4, 6, okay? A 9-volt has 6 of them, 1, 2, 3, 4, 5, 6, packed into a little 9-volt battery. And that's what you put in your fire alarm, right? So those 9-volt batteries, right, they don't put out a lot of watts, okay? Why? Because each one of those tiny little cells doesn't put out a lot of amps. Watts is amps times volts, okay? It's actually exactly what it is every single time. It's a perfect measurement. There's nothing wrong. Nothing wrong with the measurements in normal science, okay? So if it has 1 amp output and 1 volt output, it's 1 watt, okay? If it has 1 amps and 1.5 volts, it's 1.5 times 1, which is 1.5 watts. If it has 2 amps and 2 volts, that's 2 times 2, which is 4 watts. If it has 10 amps and 3 volts, which is about what a CR123A is capable of, okay, it can put out about 30 watts. Now, CR123As put out 3 volts times a little bit less than 10 amps for a brief amount of time. And then what happens is they heat up really hot. And that heat causes the thermal reaction to slow down, and the non-thermal acidic reaction to slow down. And it's not acidic, but it's a cathode and an anode. That reaction slows down when it gets hot. When it gets very, very hot. They get much hotter than 18650s. Okay? And they're more tolerant of heat than 18650s, but that's a whole nother story. So CR123s go down from 10 amps, and the amperage gets brought down to about 3 amps. And what's 3 amps times 3 volts? It's about 9 watts, which is actually still pretty decent. You can still put out quite a lot of lumens into a flashlight with